take a pen and paper with me only and start doing with this practical case study. Then when we have a different jobs, like the topic over here will be n jobs. Now you are having a number of jobs and there will be a number of machines, right? Now, how we will do this type of case study? So start practical, like write it over here. We have the jobs, machines also, and we have the jobs also. Taking an example and category, we have, say, example, different types of jobs. We have the 4 jobs over here. And if I'm talking about the machines, we have 5 machines, A, B, C, D, and E. Processing time for each jobs and the machine time is given to you, considering that one job in working in a machine A requires 7 hours, B requires 5 hours, this C 2, 3, and 9. Considering with the job 2 and with my working in a machine A requires 6 hours, this also requires 6, 4, 5, and 10. Coming up with the next, that's third category, and with the machine ABC, it requires 5, 4, 5 hours, 6 hours, and 8 hours. And the last job number 4 with different machines required 8, 3, 3 hours, and 2 hours, and 6 hours. Right? These are all in the processing time. These are all processing time which is given to us, and all the time processing time is in hours. So your answer in the unit will be hours, right? Again, what you have to do, definitely you have to find out the total sequence of the problem. Then we have to find out the idle time also, right? So start doing the question with me only. Start up, hurry up. You have to first write down the solution that what we are doing over here. Yes, we were finding out the total optimum sequence. So before starting the sequence, as it is the like number of jobs and number of machines, we will have given a two condition and we have to find the conditions are satisfied. If yes, if any of the conditions are satisfied, then only we convert these 5 machines into fixtures 2 machine as we have discussed earlier, and that 2 machine will be G and H, right? So what are the two conditions which have to check it? So write it. Condition number 1, which we have to check. Condition number 1, what is the condition number 1 is we have to find out the minimum value in machine A, and that value should be greater than equal to the maximum value of any machine B, C, D. That means you have to find out the maximum processing time of machine B, machine C, and machine D. Take the maximum time from all these 3 machines and then compare it from the machine A minimum time, right? Or we have given a two conditions. One more condition is there. One more second condition, that is minimum time. You have to find the minimum time from the last machine, that is E, and again it should be greater than equal to the maximum time or processing time of machine, same with B, C, and D. Right? So minimum time of the starting machine, that is A, and minimum time for the ending machine, that is E, and the maximum time of the middle machines, that is B, C, D. So this is the process step. I will share you the processing step by step also, but now we are doing a case study and exam. I'm giving you an example so that all the theoretical concept is being cleared in the numerical portion only. So find out the minimum time of A. You can find the minimum time in machine A is 7658. So minimum time for this is, what is the minimum time over here? Just changing the color so that it make you more identifiable. That is the minimum time over here is 6. So we write it minimum time is 6. This 6 value, that is greater than equal to maximum value of BCD. So maximum of B. Sorry, that 6 is not minimum over here. That is, sorry. Again, we have to take it and correct it. 6 is not the correct answer. We will take it 5 because 5 is the minimum value, right? So from in front of 6, we will write it 5 over here. Okay. So change the value. We will write it 5. 5 is greater than equal to maximum value of BCD. Now find out the maximum value in B is 6. In C, the maximum value is 5. and D, the maximum value is 3, 5, 6, so 6. We write it over here, maximum value 6, 5, 6. So maximum of 6, 5, 6 is 6. Therefore, that 5 is greater than equal to 6. The condition is not satisfied, so we write it false. Right. Now coming up to the second condition, minimum value of E 9, 10, 8, 6. So minimum value is 6. Write it over here, which is greater than equal to maximum value of BCD, that is 6, 5, 6. So maximum value is 6. Yes, the 6 is greater than equal to 6. The condition is satisfied, true. Once any of the condition which is given over here, condition 1, that is minimum value of A is greater than equal to maximum value processing time of BCD, anyone from BCD. The second condition or is there, so any of the condition is satisfied, it will be workful. Second condition is the minimum of E value should be greater than equal to maximum of again BCD. If any of the condition is satisfied, then the second step we come up, we convert these 5 machines into 2 machines, and that is we have taken example as G and H, right? We convert this machine into two categories, G and H. And for the G category, what we have to do, we have to add the values, right? In G, we add the values of the machine, processing time of machine of A, B, C, and D. So all the processing time of the machine A, B, C, and D is added in getting the value of machine G. And for H, we added only left the machine A and add rest of the machine, that is B, C, D, and the last one is your E. Right. This is the way of converting the above 5 machines into the 2 machines, that is G and H. And then now we will find the job sequence category over here. First, we write the jobs over here, which we have given over the question, that is 1, 2, 3, and 4. So for converting the value, that is G and H, what will we do? We add the values of A, B, C, D processing time. So A, B, C, D processing time is 7, this 5, this 2, and 3. So add the value, that is 7 plus 5 plus 2 plus 3, we will get it 17. This is the way how we'll add all the values. Same with all the jobs. So start over here. I'm starting with you only. Write it over here. 7 plus 5 plus 2 plus 3. That is A, B, C, D value. That will become up 17. That is 17 hours is required for completing one job in the G machine. Okay, this is the machine. So we're writing over here machine. Now for the 2, we will start adding 6 plus 6 plus 4 plus 5, right? Then we will get the value of 21. Coming up with the third one, we will add it 5 plus 4 plus 5 plus 6. So we'll get the value as 20. Now with the fourth category, that is a job number 4, add the value of A, B, C, D. Then we will add it, then 8 plus 3 8 plus 3, and then we have to do adding the values further. This is 8, now your 3 value, and then we have add the values in the same systematic way, right? 8 plus 3 plus the next value, that is again 3, right? And then 2, then will be equals to 16. So this is the way we will get the values related to all the jobs of G machine, right? Now converting into the value of H, that is B plus C plus G plus E. Leave behind the value of machine H. So start doing with this. Now what we will get it, we have to find out what we have to find now, processing time for H. So H is the processing time, we get it, say H, then we have to add B, C, D, and E. So what will be B, C, D, and E? Will be like adding the values, right? Which value is this one? 5 plus 6 plus 3 plus 9, right? So coming up down, we add all these values and check, we will able to find the value. 5 plus 2 plus 3 plus 9, and the total will be 19. Same with the job number 2, add the values, that is 6 plus 4 plus 5 plus 10, that will be equals to 25. Coming with the third one, that is a job number 3, 4 plus 5 plus 6 plus 8. Then we will get the value as 23. Coming with the job number 4, add the value that is 3 plus 3 plus 2 plus 6, and that will be equals to 24. So this is the way we find out, or we converted the 5 machines, that is A, B, C, G, into 2 fixtures machine, that is G and H, and we have given a job. Now the same category, what we have to do, we have to find the processing sequence, optimum job sequence of our question. So write it over here. We have to find out the optimum job sequence as per the Johnson, so that we get the idle. We, at that time, we is the less processing time for getting your work completed in effective and efficient manner. So we have jobs 4 created in the same way, 1, 2, 3, and 4. 1, 2, 3, 4. Now the same process follows up. Find out the least one for both the jobs, for both the machines, that is G and H. If the least one come up from the machine G, that is the starting one, as this is your starting point G and this is your end point H. If it is from the machine G, then we start with the starting areas from the initial start point. And if it is from the last point, least point is from the H, then we will start from the left, from the right side towards going to the left side. So find out the least value from all: 17, 21, 20, 16. The least value from all, that is 19, 25, 23, and 24. So the lowest value over here is the lowest. We have to find the lowest one, right? Just 6, 7, 8, 9, 10, 11, 12, 13, 14. This is not 24, this is 13. I'm just making some correction over here. This is 14, 23, and 14. So make a correction over here. Yes, it is 14, right? Now the lowest value is definitely over here is this value only, that is a 14. So circle this value as 14, and this is a machine. Like which machine is an H machine? So job 4 will be your last sequence value. Write it on the H part. Now deleting this job as it is done up, so we will cancel this value. Now find out the least one after 14, that will be, I think so, 17, right? This is the least one, 17. So the least one, 17, is from the machine H initial stage. That means it is again on the first one, so we write it over here, right? After 17, find out the least value, that is on the number, that is 20. That is again in machine H, starting machine 3. So 3 will be come up on the starting one, that is this, and remaining part is over there, that is 2. So we will find out the optimum job sequence, that is 1, 3, 2, and 5 is your exact optimum job sequence. Right. Coming up to the next point, what we have to find now, again, we have to find out the total elapsed time. Right. That is the main thing which we have to find out. So write it over here as a total elapsed time by all the machines, but a full total elapsed time, what is remaining over here. To start preparing or working with me only. Now you have given how many machines? 5 machines are there. So if you are doing in a paper pen and register, so use it in a like horizontal way so that it can be done in a proper way, right? So start doing with me. I'm just writing over here. Prepare the format, like we have 5 machines. So start up, and in all the machines you have to do the like in and out, same like earlier, which we have done in the many numerical questions. If you haven't done that yet, so first start doing that numerical question and then come up with this upgraded one, right? So we write it as a job sequence over here. We have given the sequence, that is 1, 3, which we have find out right now. You can check it from the upper side, that is 1, 3, 2, 4. So write it here, 1, 3, 2, 4. Yes, and we have to write the 5 machines over here. Machine A, right? Machine A has an in and out in the same way. Yes. Then again we have machine B. For machine B also we have an in and out, right? Then we have machine C, in and out, right? Then we have machine D, in and out, and then the last we have machine E, like again we have in and out values, right? So this is the way we have to do all these questions. That's better will be like you are using the pen scale so that it will be a good presentable. All right. Okay. So starting up. Now, the initial stage. What is the initial point? As we all know, whenever we're starting something, but we have to write it, we will start up again with the zero value only. Right. Now, in the given case study, as we have taken up, now the machine A, when we are doing with the job sequence, like when we're doing with the machine A, what is the value? So you just check it once. If you have noted somewhere, that's very good. Otherwise, I'm showing you once again. Just note down so that you can check it from there only how much processing time is there. So this is the question which is given to you. You can note down the processing time by machine A is 7, right? So you add on 0 plus 7, that is 7 value will come up, right? So you can note somewhere if it is good, then it will be very easy for you. Okay. So start off preparing the total elapsed time in the same scenario question as we have done earlier. So 0 plus 7, that will be 7, right? And for 3, now it will become of 7 over here from this value, right? This is from this. I'm just joining it so that it make you more remembering. Right, 7. Now the processing time by the machine A for job 3 is 5. 7 plus 5 will be 12. You can directly also write it. I'm just writing for your remembering. Like again, how much time is there? 6 times. So 6, that is 12 plus 6 is 18. Now write it over 18 and 8 hours is there. 18 plus 8, then the total will be 26. Right. Now when the machine A is working on, till that time machine B has to remain idle, as the in time will be this one only. So here the 7 will come up. Right. Now for the job B, how much processing time is there? 5 hours. So 7 plus 5 will be 12. Here it is 12 and here it is also 12, so we write it 12 only. Then the processing time is 4. 12 plus 4 will be 16. Right now the point is remembering this is 16, though the B has done their work on at 16 hours, but the job number 2, when it is doing processing in machine A, is doing at 18 hours. So this machine has to wait for 2 hours, remain have to idle because it will be start at 18 only, right? Remembering this point. Now the processing time is 6 hours. 18 plus 6 is equals to 24. How this come up? From the same case scenario which we have done up. That is the processing time which is given on the question. Now this is again 24 now, and it is 26. That means it has done their work earlier. Wait for 2 hours, then will come up. That will be 26. And 26 plus 3, that is the processing time, will be 29. Coming up with the next machine C. Machine C will remain idle as till the work being done by the machine A and machine B. So here the 12 will come up in time, that is out time of machine B will be the in time of machine C. So 12. Now the processing time for this is 2 hours. That is again it will come up 14. Right. Now again this is 14 and this is 16. So we have to take 16 only over here. He has to wait up machine and the 5 hours. 16 plus 5, that will be 21. Right. Now it is 21 and 24 again. It has to wait up machine for. Then we have the 4 hours for the processing for 24 plus 4, that is 28 hours. This is 28 and again it is 29. Remember point over here. Again we take it 29 and the processing time is 3 hours. Adding that value, then it will be become 32 hours. The same process now again the D cannot work once the machine work is done by A, B, C, and then the in time will be 14 over here and the processing time is 3 hours. So 14 plus 3, that will be equals to 17. Right? Coming over here, this is 17 and then this is 21. We have to take it 17 or 21. It will be 21. The machine D has to wait up now as the process one job one you have done up, but 3 will become up when the it will be done by both the machines A, B, C. Then will be only the D will work out, right? Now the 21 plus 6, that will be equal to 27. Now this is 27 and 28, again 28 and the 5 hours. 28 plus 5, that will be 33. Now this is 33 and 32. Now the machine C has to wait up and we will take 33. In all together, you can remember one point, that this value or this value, that is the out value of the previous machine and the out value of the current which we are doing it, we have to take the higher value, right? Then 33 plus 2, that will be 35. Coming up for the machine E, that is the last machine, will take up again 17, and the processing time will be 9. 17 plus 9 will be equal to 26. This is 26 and 27. Again, we will take only 27, higher of 26 and 27. Processing time is 8. Then 27 plus 8 will be equals to 35. Again, this is 35 and 33. Now the D has to wait up. So we write it 35 and the processing time for the machine is 10. So it will be equals to 45. And the last, yes, it is 45. Processing time is 6. So the total will come up 51. Here we go and we able to find out the important 3 points which we want to calculate up. That is the main important thing we are finding, actually waiting to find out. That is the total elapsed time, right? Which we want to do up. That total elapsed time over this question is 51 hours. Write it over here, 51 hours, right? And then we have to find out the idle time for all the machines. We have to find out idle time for machine A. Second point is idle time for machine B. Yes, we have to find out the idle time of all the machines individually and then we can add up, right? Idle time for machine C, idle time for machine D, and the last we have to find out idle time for machine E. Right? Now we have to find out how same process which we have discussed earlier. Start up with the first one, that is machine 1. The total elapsed time is 51 and the machine A has completed all their tasks at 26 hours. So till 26 hours he was in working in the machine. After that a machine A remains idle. So 51 minus 26, that will be 25 hours is an idle time for machine A. For machine B, if we are checking the in and out time, the out time is 29. Very true. We just subtract in the same way 51 minus 29. But here we have to check it one by one from the one job. Like when the week started working, yes, it started working at 7. Right. So that means the machine B is have to wait for 7 minutes when we are processing a job of 1. Coming up further, see it is 12, the remains 12, 16, but now this is 16 and this is 18. So that means again it completed the job third by the machine B at 16 hours, but when they started up with the next job sequence of 2, has to wait for 2 hours. So write it over here as 2, right? Then proceeding further, this is again 24 and this is 28. 26, that means 2 hours more. Then adding all these values and calculating, we will find out it is 33 hours. That is an idle time by the machine B. Right. Coming up further with the third machine, that is machine C. Find out again in the same way, 51 R minus, first we find out the last out time by the machine C is 32. So 51 minus 32, that is the end point. But we have to see the sub starting points also from the job 1. So from the job 1, we have to check up, yes, machine C has for 12 hours in the initial stage of job 1. Then find it over here, it is 14 and 16, right? That means 2 hours over here in the job number 3. Coming up further, it is 21 and this is 24. That means 3 hours over here. And in last, this is 28 and this is 29. Again, the 1 hour the machine C has to wait up. So calculate all these figures and you're able to find out the value of machine C, that is 37 hours. The machine C remains idle. Now coming up with the machine B in the same process, 51, that is the total elapsed time, and machine D, the second last machine idle time is 35. So 51 minus 35 hours, that is the ending point. But we will start up from the initial stage. What we find out, yes, machine D wait for 14, right? So we add 14 first of all, and then check the next values in the same process like for the job 3. Yes, check it. It is 17 in the first job until when we processing the third job, it will be 21. So there is a difference. Yes, you have to consider all these differences. So the difference, what we find out, then this wind up the output 17, but start up on 21. To find out, so 4 hours is there, which was done up, right? And coming up with the next, this is 27 and 28. This is also 1 hour. And this is 33, 33. That will be not considered. So that means 4 plus 1, we have to take it. 4 plus 1 over here, right? And we, then when we find and subtract all these values, we find out 35 hours. That is total 35 hours. Machine D remains idle, right? Now the last, that is the machine E. The machine E has a total elapsed time of 51, and yes, it completed their work. Out time is also 51. But as usual, discussed up, we have to take the step one from the starting stage only. Yes, machine D E have to wait when the machine work is going on A, B, C, D. That means it wait for 17 hours first of all. And then it is 26 when it is completed, but started the next process at 27. 1 hour over here, 17 plus 1. And then this is 35, 35, 45, and 45. No idle time rest. So add these value, that is 17 and plus 1. Now calculate this figure and we get it 18 hours over here. So we can add all the values of machine A, B, C, D together. We get the total elapsed time. Ma'am, do you feel like, do we have any shortcut for doing all these questions? A little bit shortcut, finding the idle time. It can be possible that you can find idle time in this way, or else it is also one more solution for finding the idle time, helping you. Like in other words, you can find the solution in this way also. And write down with you only. In other words, we can find the idle time, and that will be, what is the way to find out the idle time? First, sum up all the values of the time taken by the machine A, B, C, D. So come up with the case study number 1, that is on the top. Add all the values taken by the machine A, B, C, D. So add the values. Here it is 7 plus 6 plus 5, that is taken by or the machine A, and plus 8. So we add all these values and we find it that all the work will be done in 26 hours. Same with this machine B, when we add the values 5 plus 6 plus 4 plus 3, and we get it, all the work is done by in 18 hours. Same with C, that is 2 plus 4 plus 6 for 5 plus 3, then it will be completed all their work at 14 hours, right? With D, when we are going on 3 plus 5 plus 6 plus 2, we find all the work will be done in 16 hours. And with the E, when we adding up 9 plus 10 plus 8 plus 6, we get it, the work will be done in 33. So now remember this, the total processing time by the machine A, B, C, D is 26, 18, 14, 16, and 33. So I'm writing all these values on the last part so that you can check it whether what we done up in the processing style of like this, are we getting the same result when we're doing in this way. So write it over here, total time, total processing time by machine A. What is the total processing time by machine A, by machine B, by machine C, D, and E? As we added up, then we just write it over here so that we easily able to do the calculation. This is 26 hours, and the machine B is taking how much time? That is 18 hours, right? And what about C is taking about 14 hours, which we added earlier. Now we're talking about the D. How much time is taken by the D is 16 hours, and about the E, it is 33 hours, right? Now, what is the total elapsed time? As we all know, the total elapsed time is 51 hours, right? What we will do, just subtract it over here. I'm just showing over here only so that you can do the calculation right down. Okay, so start doing it. What is the total elapsed time is 51. We have to find out the idle time. So what we will do, we will subtract the values, right? So start doing it like this. Over here only 51 minus 26, right? 51 minus 26 so that we able to find out the idle time, right? So do it. 51 minus 26 over here. The next one is 51 minus 18, right? Is equals to 51 minus 14, right? And the second last, 51 minus 16, find out the value, and the last machine E, that is 51 minus 33, right? You can check it whether you are getting the same result or not. But either we have to do in that way or this way. That depends upon you. Approximately for you only. But yes, the answer is same. Yes, definitely the idle time is 25. 15 minus 18, that will be 33. This one, 51 minus 14 will be 37. 15 minus 6, that will be 35. And this is 18. So this is the way you can find out the total idle time by machine A, B, C, D, and E. So this is the way we can complete our new topic, that today what we have done in the case scenario of n jobs and n machines. Like though it is a lengthy process, but the concepts are the same. What is the concept? That first you have to find out the conditions. If the conditions are satisfied, we have given two conditions. If any one of the condition is satisfied, then what we do, we convert that into the two fixtures machine, that is G and H. The same process for getting the value of G, we add the starting four machines, that is A, B, C, D, and for H we add B, C, D, E. Then we have to find out the least one. If least is coming from the machine D, start with the initial state from H, then from the end. And the format, we will find the total elapsed time with the same procedure, A, B, C, D machine with the proper job sequence, and then we have to find out the idle time. For idle time, I've shown you the two process. It's up to you which process you are following now. But remember, you were dealing with the concept that is known as quantitative techniques for manager, and this is the topic which is covered over here is a job sequence. Yes, you have to find the proper job sequence. What is the reason behind doing this? Is to find out that your idle time is less and your processing time is to be very less, so that you complete your jobs by processing by the each machine, and your answer is in a very much effective way. You have to make a balance. You have to make the strategies which is given by the Johnson's algorithm, and you have to follow the steps which is given by them. Yes, it is a little bit lengthy process, but it's a very easy mathematical calculation. You just have to remember the rules and just follow that rules in the numbers. Once you are good in that, you will definitely do all these questions and you will be fine.